Good morning, everybody. My name is Schick from EUMETSAT, and I'm talking about the component of the Destination Earth data lake. You've seen this picture before. Destination Earth is built by the 3 E's with 3 components. We have the core platform, which is the user-facing element. We have the data lake, which is for the access to the data, and we have the digital twins. It's all our self-standing components. It's important to notice the components do not use a common infrastructure. We get quite often asked on this one. And on the Destination Earth data lake, we use the edge computing paradigm, processing near data. The Destination Earth data lake itself is a self-standing component. It's built from geographical distributed physical elements where you can access seamless to all DestinE data. Data and information is provided from a large number of external data spaces and regardless of the data and location. One of the paradigms that was mentioned before that we support as well as part of the service near data processing and big data workflows. This is an overview of some of the services I will explain on the next slide, but the user-facing services which are exposed through the core platform is discovery, data access, and big data processing. So now here, I think if you remember something from my presentation, then I would like that you remember this one here, on which I want to focus a little bit. Here, this is from the view of the Destination Earth data lake. You see here we have 3 kinds of services which are exposed. There's the discovery service where you can find information about the data that is offered from the data lake. You can find as well services that is offered by the data lake. You have, of course, the data access element, and you have the big data processing. This is the kind of heart of service, and that one is made accessible through the core platform. We have here everywhere the sort of edge computing on the next layer outer ring. So the infrastructure that we have, it was mentioned before in the talk from Thomas that we have data bridges which are close to the HPC computer. We have a central site where some services are run, and we use here the paradigm of edge computing. So then there is a kind of fusion of data. So what is also unique in the Destination Earth data lake is we have the DT warehouse, where actually the data from the HPCs, from the model runs, is transferred. That is available in the DT warehouse. And on the other side, we have the fresh data pools where data is available through different data spaces. You see then on the left side, data spaces. Here are some examples with which we will eventually connect or maybe interact. So there was this morning the talk about the energy. We have the health sector, etc. So it's way beyond Earth observation. And then on the other side, on the right side, we see sort of twin integration. And on Destination Earth, we start with 2 twins. And in cooperation together with ECM WMF, we have standardized the interface from the HPCs to the data lake in the form of a data bridge. So we did this together, and we have their reference architecture. So it's quite important to know. So everything what we're doing here towards the data spaces, towards the twins, it's built on reference architectures, which can be extended and expanded for the future. So key points are as well that here you have all the data together, so you can do data fusion. And it was mentioned in some initial talks as well by the Commission, we need this very fast iterations. We need this interactivity. And you cannot just do it by having a model run, transferring the data somewhere in the world, and then trying out the data if it fits or not. So here we have the small iterations. The data is available in the data lake. You can assess it then, you can take it away, you can use it in different services. So the distributed processing near the data is possible, reference architecture, and then also most important, it was not mentioned too much, so there are questions that we want to resolve on AI/ML. And for this, you need to transform the data maybe into models, and you need to do a fusion of the data in order to use AI/ML runs. But all of these services, there's as well on the user-facing side on the core platform. Then Ines on the next talk will explain as well how from the user-facing side, from the core platform, you can interact with these services. On the right side, you see the key points that the EC mentioned this morning in the talk that we're trying to address with DestinE. So here are some more examples drilling down into the services itself. And I mentioned before the discovery service. You can see the data portfolio services. And then we have a portfolio of things that you can do. You can access twin data, federated data sets. Then you can have user-generated data, which could be outputs from use cases run on Destination Earth, on the core platform. They can be stored in the Destination Earth data lake, and then they can share it with a broader community. In the fresh data pools, what was mentioned as well on the previous slide, so we have a lot of on-demand things. So Thomas mentioned the on-demand for the twin execution. So maybe you can zoom into regions, you can scale, and also for your use cases you need to run, you can on demand have data prepared in advance in the data lake that you can use then for meshing up. And then for the big data processing services, these are optional. They can be used on top to use infrastructure and tools. We have the ability to have hosted applications. So there is a certain amount of hosted applications foreseen at the beginning, but that will involve with interaction with users. So depending on your feedback and the uptake may, over the lifetime of Destination Earth, the applications can change. And the same way as well, the hook services, which are sort of workflows. So we will adapt. And so quite important is that the framework that we establish is flexible for change for the future, for your demands. Here's again a mentioning of the three. There are some examples. So in the infrastructure, we will have obviously GPUs for efficient processing. Maybe if there's a need in the future, we could have TPUs for AI/ML to run TensorFlow, for example, and suitable close to the data. For the Stack service, we envisage at the beginning to have a Jupyter Hub ecosystem, task processing for distributed, but that can change. And then on the right side, it's for workflow execution. The idea is as well that users can mix and match. And this is also, I'm coming back to what Thomas said before, you can do AI/ML at the digital twins. You might do it in the Destination Earth data lake. You might do it on the core platform. So depending on the need, things can shift from one way to the other, and you combine services as it's needed for the use case. And it could also be throughout the execution of the use case that you do something maybe initially on the Destination Earth data lake. Later on, you move to the core platform, or if it's better suited, it's moved to the twins itself. So this is a bit the timeline that we envisage for the data lake implementation. So, I mean, it's in line with what you saw on the other slides. We ramp up throughout 2023. So there will be a minimum viable service available in Q3. And the ramp up goes up to Q1 2024, and then there's maybe another round of requirements and evolutions for the continuation. Data portfolio. So quite important to notice is we have a user-driven data portfolio. So the data portfolio is an initial one that we have right now, matching the initial talks of use cases and needs, but that will evolve over time. So the key point is here, it's user-driven. So we listen to you, we speak to you, and it will evolve for the needs, and it will be beyond EU. That's very important. So we have digital twin data, so initially also that can also evolve. So there may be more twins to be integrated in the future. Some examples of federated data sets